Hello everyone, welcome to business mathematics business, something like that. And this time we will learn about limits. Oh, by the way, I'm Aditya Purwasantika and not Dr. Iha Magdalena, as you may have guessed from the voice alone. Okay, let's start with an illustration of limit. So the limit itself is the study of the behavior of function fx as x approaches a number c. This c itself can be in the domain of f or not. So let's say we have a cx cost function of a plant with x is the percent of the plant capacity is being used. Let's say we want to know what the cost is if 80% of capacity is used. We can try by evaluating CAT, but this results in a nonsense fraction nil per nil, so yeah, that's a dead end. But we can try to study Cx when x is near 80. We can see in the table that when x approach 80, Cx will approach 7. Remember, CAT itself doesn't exist, but nearing 80, Cx will be 7. So we say limit x to 80 from Cx is equal to 7. Here's an illustration of limit x to c from fx equals to L in Cartesian coordinate form. Here's another example of limit. So let's say we want to find limit x to 1 of square root x minus 1 over x minus 1. So we can see from the table that if we approach 1 from left and from right, we can kind of guess that 0.5 is the answer to that. Here again is the reminder that limit is the study of behavior of function near a point, not at that point itself. We can see from these three graphs that all three functions have a limit of f in 3 equals to 4. The only difference between those three functions is the value of f3. We can see the left function has the value of f3 4 and the middle function have the value of f3 is, well, somewhere above 4, and even better, f3 is not defined in the right function. On the other hand, these two functions don't have limit as x approaches to 2. The left one, we will not dwell too much on that, but on the right one, we will go back to this function later. And here are the properties of limits, or to be exact, the arithmetic properties of limits. So we can see that arithmetic operation and limit can be done in any order. So let's say if we want to multiply two functions, we can do the multiplication first and then determine its limit, or the other way around. Now you can pause the video to take notes or to bask in the glory of these forms. And these two properties of limits are so trivial that we often use this subconsciously. Those properties are the limit of a constant is the constant itself, and the limit of x is c as x approaches c. Here are some exercises that you can try. So you can pause the video and try to solve this. Number 1 from the exercise before is an example of polynomial functions, while number 2 is an example of rational functions. The great things about those two functions are to determine the limit, we can just evaluate the value of the function. The only exception is when the denominator of the rational function is 0, because there will be a division by 0, and that is the biggest sin in mathematics. The next thing we have to be careful of is indeterminate form. We meet this form in our very first example. When we meet this form, there are few things that we can do. One of those things are factorization. So you can try to factorize these two examples to determine its limit. The last topic in this video is limits involving infinity. The first one is limits at infinity. This topic answers the question of if x get larger, what happens to the function itself? Will it also get larger? Or maybe larger but the other way? Or maybe it will get closer to one value, one finite value. The method that we can do to determine the limit at infinity, you can see in the bottom blue box, or maybe the top blue box. So let's say we want to find a limit x to infinity of x squared over 1 plus x plus 2x squared. We divide both denominator and numerator by x to the power of 2. This is the highest power that appears in the polynomial. And then we simplify it and we use the property of limits and we get the result. In this case, half. The second one is infinite limits. As the name suggests, this is a limit which value is plus infinity or minus infinity. In this example, we have limit x approaches to x over x minus 2 square. We can see from the graph that there is limit value at plus infinity. And so we come to the end of this video. See you in the next topic. Maybe. I don't know. See you and thank you.